The topic what we are going to see now is CPU scheduling, which is in Unit 3. So what is the CPU scheduling? So it's nothing but it's a concept in OS. So this decides which process in the ready queue it gets the CPU next when multiple processes are waiting. Its main goal is what in sense? It is to maximize the CPU utilization. So you can just see the scheduling criteria. In the scheduling criteria, it actually maximizes the CPU utilization and the throughput, and it minimizes the turnaround time, waiting time, and the response time. So let's know what is the CPU utilization. So that's nothing but keeping CPU busy is what actually CPU utilization. And apart from that, the throughput also should be maximized. So throughput is the number of processes completed per unit time. So in a time, how many processes have been completed is what called as throughput. And turnaround time, the time taken to complete from the submission time is what called as turnaround time. And the waiting time is the total time a process waits in the ready queue is called as waiting time. And the response time is nothing but the reduced time between the submission of a request and first response is what called as the response time. So here the turnaround time, waiting time, and the response time should be minimized, and the CPU utilization and the throughput has to be maximized. And the very first things we are going to see the different types of scheduling that is actually you can just divide into main different two types. Actually, it's preemptive and non-preemptive. So when you can just say preemptive, since the CPU, where it has been forcefully taken away from a process, uh, if a higher priority process arrives, or it can be the time quantum, that is round robin methodology. In round robin methodology, uh, if another process enters, so during that time, so if the CPU has been forcefully taken away, so the from the process, it is meant as preemptive. And non-preemptive, till it completes, or till the process completes, when from the starting till it completes, it will not be it will not be sent out. So it cannot be interrupted until it finishes. So no one can voluntarily release or release the CPU unless otherwise by requesting IO. Other than that, it cannot be forcefully come out of it. So that is what called as non-preemptive. And under preemptive, there are some divisions. So that is actually, you can just go ahead with the shortest remaining job or remaining time first, and priority scheduling, and then round robin methodology, and then the longest remaining job first. And in non-preemptive, it's actually shortest job first, first come, first serve, and then the longest job first and highest response ratio next. So these are some of the different types of preemptive and non-preemptive. And now we're going to see about shortest job first. So as per the word says, shortest job first, what we are going to do over here is we're going to give importance for the shortest or the smallest burst time process. We're going to give time of for the process which is having shortest burst time. the execution. So this is actually this type of scheduling can be preemptive or non-preemptive. So when it is just told as shortest job first, it is meant as non-preemptive shortest job first. So explicitly they may say as non-preemptive shortest job first, or just shortest job first. So it is meant as non-preemptive. So what happens over here is once a process is being started, it runs until it finishes. CPU is not taken away until it has been completed. And there is another method, what is JF, that is actually preemptive SJF, or it has been also called as shortest remaining time first. So that is another what type of shortest job first. So here what it does is a new process arrives with a smaller burst time than the remaining time of the current process. So suppose any of the smallest burst time arrives. So during that time, CPU is being pre-emitter and it has been assigned to the new process. That is what happens in pre-emitter ESJF. So now we'll just see detail about ESJT or non-preemptive shortest job time. So here you can just say we are having what 5 processes. So when it is shortest job time, it is meant that the burst wherever the burst time is lesser, so we do consider that will be the first for execution. So when in this, you can just see there are 1, 6, 1, 3, 5. So these are different burst times of the processes. So the least processes actually it is 1. The least process is 1. But what happens is this least process here where you have 1 and here another burst time is 1. But when does it enter over there and enter inside the CPU instance? In the arrival time is actually 2 and here it is 4. So during 0, no, what till 2, it has to wait. Only after that it can be done. So that will become the CPU will be idle for 2. So instead of that, what you can do is we you have to check out that there is another process P2. So this process P2, what it does is this has entered in the starting time when the CPU is in 0. During that time, it has entered. So the CPU will be addressing or it will be executing process 2. So when it executes process, the first one, it will be P2 will be executed. Okay, so P2 will be executed, and when it executes, it is actually it takes 6 units. So you can just see the Gantt chart. So Gantt chart it just explains you very clearly. You can just see at 0th time or in 0 unit. So what happens? P2 enters over there, and since it is non-preemptive, so till it completes its work, it has been executed. So 6 time, okay, 6 unit time, it actually works on it. So till 6, this P2 is being executed. And when it finishes the execution of P2, so during that time, you can just see that there are there is the other process I have entered during that time. So what P1 has entered, and similarly P3 also has entered as 4 at 4, and P4 has entered as 2, and P5 also has entered at 1. So all the processes have entered before it completes P2. So now what happens is we are just going to just check out which particular process enters. So during that time, we can just see you can what you can just check out the burst time, least burst time. So in that there are two least burst times, 1 and 1. Okay, so P1 is also having least, and the same P3 also having the same number, so least burst time. So during that time, what we have to do is we have to go ahead with the a first come first serve process. So first comes first serve methodology is being used over here. So P1 entered first, so it entered as 2. So that has been so now process 1 has been executed. You can just see here process 1 has been executed, and that has been done for the burst time of that is 1. So till 7, so 7 unit time, this particular P1 is completed work. And next, the 4 enters inside. There is a 4 in the, sorry, the P3 enters. So P3, it enters and that completes at 8 unit time. And then in these two, that is P4 and P5, you can just see P3 has the lowest burst time. So P4 is being executed. So P4 and this P4 is being executed for 3 unit time. So it finishes its work by 11. And then next you can just see there is actually the last, there is P5. P5 actually what it does is its execution time is 5, so it has been executed and it completes its work as at 16. So here when you just calculate the burst time, the total burst time and the time taken over here in the Gantt chart, both are similar. So here you can just see 7 plus 3 10 10 plus 15 16. So 16 is the total time, burst time. And similarly here the Gantt chart also you can just see it is 16. So hence the CPU was not idle even for 1 unit time. So it was being utilized. So this is the maximized utilization is being done over here. So now we'll just check out the completion time frame, the completion time. We can just calculate the completion time. So this process 1 was being completed at 7, and the process 2 was being completed at 6, and process 3 you can just see it was being completed at 8, and process 4 was being completed at 11, and process 5 was being completed at 16. And then we're going to find out the turnaround time. So turnaround time is nothing but the completion time minus the arrival time. So how long uh, from the arrival time till it completes, how long it was there. So we'll just check out that. Okay, so completion is 7 and the arrival was at 2. So it was what the turnaround time was 5. And here you can just see the completion was 6 and it arrived at 0. So the turnaround is 6. And similarly over here you can just see the completion was 8. 8 minus 4 is 4, and here 11 minus 2 is 9, and 16 minus 1 is 15. And when you just calculate the average is actually around 7.8 time actually it was being the turnaround time was being there. And waiting time, when you just calculate the waiting time, the turnaround time minus the burst time, when you just minus it out, automatically you can find out the way how long it was been waiting. So here you can just see it was been waiting for 4 unit time, and this was not waiting at all, so it was 0, and P3 was waiting for 3, so it entered at 4, and it was being actually what P3 was entered as at 4 it entered, and it was being given only at 7. Okay, 7. So what happened, so the waiting time was actually 3. And the next was P4, so P4 entered inside the CPU at 8. Okay, but it came inside, the arrival time was 2, so you just minus, when you minus these two, 8 minus 2 is nothing but 6, or turnaround time minus burst time, anything you can just do it out. And P5 is 15 minus 5 is 10, or you can just go ahead with 11 minus 1. Okay, you can just say the entry time was 11 and the arrival time was 1. So 11 minus 1 is actually 10. So this is the waiting time. So now when you just go ahead with the response time. So response time is very similar. Basically, it's very similar when it is equal, when the CPU is equal, when the CPU is what the time taken. That is the CPU. If it has not been weighted completely, if it is seen. So it is meant as actually, it is actually the response time and the waiting time will be similar. So it's 4, say 4, 0, 3, 6, 10, and 4.6 we have got. So the average time when you just see, you can just see that it's 4.6. So this is what actually meant as shortest job time.